Assalamualaikum and hi everyone. Welcome to our CHM256 video presentation. We are from group F4 AS1204-1 and today we will be presenting on determination of ascorbic acid in oranges. Okay, before we begin, let me introduce my group mates. First, I'm Najihah binti Ruslan, Amiris Jasmine binti Syahril Nizam, me, Nurul Najihah Hanim binti Zairul Nizam, Muhammad Haris Hafizi bin Jafri, and lastly, Muhammad Nuklis Haikal bin Nur Azman. Okay, to begin with, what is ascorbic acid? Ascorbic acid, also known as vitamin C, is an essential water-soluble vitamin that plays a vital role in various physiological functions, including acting as an antioxidant, supporting the immune system, enhancing iron absorption, and contribute to collagen synthesis. Also, citrus fruit, particularly oranges, are well-known dietary sources of ascorbic acid. Also, determining the vitamin C contents in food product is important for nutritional labeling, quality control, and ensuring that the nutritional value is maintained during process and storage. Volumetric analysis is a method in quantitative chemical analysis which the amount of substance is determined by the measurement of volume that the substance occupies. It commonly used to determine the unknown concentration of non-reactant. In this experiment, the redox titration is used, which the amount of titrant used allow calculation of ascorbic acid concentration. What is the objective of this experiment? The objective of this experiment is to determine the percentage of ascorbic acid in orange, which is an important nutritional component of human health. Also, to practice and apply volumetric analysis techniques in analytical chemistry. Move on to the type of volumetric analysis. There are 4 types of volumetric analysis, which is acid-base titration, complexometric titration, precipitation titration, and redox titration. In this experiment, the redox titration is used.
So, please lend me a time to explain about determination of ascorbic acid in orange. But let me introduce myself first. My name is Najihah binti Ruslan. My ID is 2023-687744. So, as for the theory, the quantity of oxidizing or reducing agent present in a redox reaction can be calculated from result of titration by using the balanced redox equation. This tells us the molar ratio of reactants and the formula triangle linking number of moles with concentration and volume. Acidified permanganate is a common chemical used in a redox titration. An indicator is not required as purple permanganate solution turns colorless when reduced. The mass of vitamin C in tablet can be determined by redox titration. An iodine solution of non-concentration and starch indicator are used. A vitamin C tablet is dissolved in deionized water in a beaker and transferred to a 250 cubic centimeter standard flask. This is made up to the graduation marks using deionized water and the washings of the beaker. 25 cm cubic of this solution is transferred by pipette to a conical flask and a starch indicator is added. The iodine can be added by burette until the vitamin C solution turns blue or black. This can be repeated and the average is vitamin C concentration cannot measure by acid-base titration because there are many acid and bases in foodstuff, as well as other products that interfere with acid-base titration. In one way to determine the amount of vitamin C in food is to use a redox titration. The redox titration is better than acid-base titration since there are additional acid in a juice, but few of them interfere with the oxidation of ascorbic acid by iodine. Iodine is relatively insoluble, but this can be improved by complexing the iodine with iodide to form triiodide. This is the equation. and triiodide or C-diced vitamin C to form dihydroascorbic acid. Okay. As long as vitamin C is present in the solution, the triiodide is converted to be iodide ion very quickly. However, when all the vitamin C is oxidized, iodine and triiodide will be present, which react with starch to form a blue-black complex. The blue-black color is the end point of the titration. The vitamin C titration procedure is appropriate for testing the amount of vitamin C in tablets, juice, and fresh or frozen fruit and vegetable. The titration can be performed using just iodine solution and not iodides, but the iodide solution is more stable and give a more accurate result.
So for the methodology of determining ascorbic acid in oranges, for materials, reagent, you have to have potassium iodide solution, starch solution, standard ascorbic acid solution, and distilled water. And for apparatus, you have to have burette, Erlenmeyer flask, volumetric flask, conical flask, beaker, and pipette. So for the procedure in obtaining the ascorbic acid in oranges is, first you have to obtain a sample of fruit, and you have to juice the orange using a juicer and filter the liquid through a filter paper to obtain the analyte. And for the preparation of 0.005 molarity of potassium iodide solution, you have to have weigh 2 grams of potassium iodide and 0.3 gram of iodine crystals, and transfer it into a 100 ml conical flask that already had 50 ml of distilled water. Let it dissolve and transfer it into a 1 liter of volumetric flask, and then dilute it with distilled water until it reaches the calibration mark. So next, the preparation of 0.5% of starch solution. Weigh 0.25 gram of starch powder and place it in a 100 milliliter beaker and add 50 ml of distilled water. Heat the mixture on a hot plate at 80 degrees Celsius for 5 minutes. So next, the standardization of ascorbic acid solution. So first, you have to weigh 0.25 gram of ascorbic acid powder and transfer it into a 500 milliliter volumetric flask and add distilled water until it reaches the calibration mark of the flask. Then the standardization of iodine solution, and to prepare the iodine solution, you have to pipette a 20 ml of standardized ascorbic acid solution and is transferred into an aluminium flask, and drop 1 ml of 0.5% starch solution into the flask, and then you have to rinse the burette with a small volume of iodine solution and then fill 50 ml of iodine solution into the burette. Place the flask that is contained with the ascorbic acid solution on a hot plate magnetic stirrer and titrate the solution until it reaches the end point. You know its end point reached when the first sign of blue color appear after 20 seconds of titrating the analyte. And then you have to repeat the titration 2 more times. Lastly, the titration process of the filtered juice sample in order to obtain the ascorbic acid from the orange from the sample is, first, that you have to transfer the filtered juice sample into a 250 milliliters of conical flask, and for each titration, pipette 20 ml portion of the orange juice into the aluminium flask and drop 1 milliliter of 0.5% starch solution into the flask. Add potassium iodide solution into the burette as the titrant and continuously swirl the mixture in the flask while titration occurred. Record the result into the table and repeat titration 2 more times.
After the experiment, we can now move to the calculation to determine the amount of vitamin C in oranges. Presented here are the results from the previous studies of similar topic. First, we need to calculate the average amount of titern used in the experiment by dividing the net volume of titern used and the number of titration. So, we get 11.867 milliliter. Then, we need to determine the molarity for vitamin C. To do that, we need to look at the balance equation for analyte and titern. You could see that 1 mole of vitamin C reacts with 1 mole of iodine. We already know that the concentration of our titern is 0.005 molar, and the volume of vitamin C used is 20 milliliter or 0.02 liter. By plugging this number and the average titration that we find previously into this formula here, we will get 2.968 times 10 power of negative 3 molar for the molarity of vitamin C. Now, we need to find the mass for vitamin C. To do so, we can just multiply the molarity by the volume of vitamin C used to find the mole of vitamin C first, and then we need to multiply the mole with the molar mass of vitamin C so that we could get the mass for the vitamin C, which is 0.0105 gram. Now that we have the mass of vitamin C, we could find the weight per volume percent by dividing the mass with the volume of sample and multiply those by 100. We should get 0.053%. What this means is that in 100 ml of juice from an orange, there is 0.053 gram of vitamin C in it.
In conclusion, oranges are a good source of vitamin C, which is important for health. The vitamin C content in orange juice was determined using a redox titration method with iodine solution. In this method, iodine reacts with ascorbic acids in the juice, oxidizing it into dihydroascorbic acid, while iodine is reduced to iodine ions. As long as the vitamin C is present, iodine is consumed and no color changes occur. When all the vitamin C is oxidized, excess iodine reacts with a starch indicator to form blue-black complex, signaling the endpoint of the titration. This method is preferred over acid-based titration because it specifically measures vitamin C without interference from other acids in the juice. Overall, the experiment shows that redox titration with iodine is an effective way to measure vitamin C content in fruits like oranges, highlighting their nutritional value and the usefulness of this analytical technique in food chemistry.